Over several videos, I'll set forth the idea of the antiderivative of a function, the concept of the so-called definite integral as a way to compute area under a curve, an informal argument for the almighty fundamental theorem of calculus, and a bunch of notation along the way. So, the antiderivative. Suppose you have some position function, 5t to the fourth plus 3. We then know that the velocity function for that object can be found by finding the derivative of position with respect to time, dx dt. And we know the rule, 4 times 5 gives us 20, reduce 4 by 1 to give us 3. The constant term disappears, so 20t cubed is the derivative. But if instead what you knew was the velocity function only, could you sort of work backwards to find the position function? So this is what we call the antiderivative, this working backwards. So you would just need to reverse that rule. We'd take this exponent, 3, add 1 to it, so increase 3 to 4, and then divide 20 by the 4. Put generally, if y equals ax to the b, then the antiderivative of y can be found by this reverse rule. The antiderivative of y would be x to the b plus 1, and then we would take that a and divide it by b plus 1. So applying that here to our velocity function, we're going to take t to the 3 plus 1, so it'll be t to the fourth, and then we'll take 20 divided by 4. So our position function that we're trying to recover should be 20 divided by 4 times t to the fourth. So that's 5 times t to the fourth. And yes, indeed, that is the first term in our position function. But you see there's a problem. We don't get the plus 3. Looking at our velocity function, we can apply the reverse rule to get this term, but there's no way to recover that plus 3. There's no information here that tells us that there should be a plus 3. Apparently, there's not enough info here in your velocity function to get back the full position function. We need an extra piece of info. So it seems that we need to modify our rule here in finding an antiderivative. This rule is good to get us a term like this, but the plus 3 is some extra constant term, a constant term that disappears when you take the derivative. There's no way to get that constant term back, but we know it's there. So our rule for the antiderivative has to include an extra plus some unknown constant term. So 20 over 4 t to the fourth plus some constant term. We know this constant could be there, but an extra piece of info is necessary to determine what that constant term is. Is it plus 3? Is it plus 11? We don't know, but it could be plus something here. So hence, we always have to add some constant term, some unknown constant when we find the antiderivative. And if we want to know what that extra constant actually is, we have to be told. So that could look like this. Suppose we were told that the velocity as a function of time was 20t cubed, and here comes the extra piece of info. If we were told that the position was 83 meters when t equals 2 seconds, that's now enough information to recover the full position functions. So what we would do is find our antiderivative of the 20t cubed, which gives us 5t to the fourth plus c. So then apply this information. So x is 5t to the fourth plus c, and we know that when x is 83, so put in 83 for x, that occurs when t is 2 seconds. So 5 times 2 to the fourth plus c. Then 2 to the fourth is 16 times 5 is 80. Subtract that from both sides. 83 minus 80 is 3. And we discover that c must be equal to 3. Then we can go here and put in 3 for c. So this extra piece of info was enough to determine the identity of that unknown constant. We could have also been told something like this. The extra piece of info could have been simply x equals 3 when t equals 0. So the initial x was 3. If we'd been told that, then we would go back here and say, okay, at the initial time 0, when time was 0, that term disappears, and x was 3 at that time, therefore c equals 3. So that could have been our additional piece of information. And in fact, very often, the extra piece of information we're given is the initial position. All right, so let's restate our antiderivative rule. Now that we know about this additional constant we need to account for. So if y equals a times x to the b, then the antiderivative of y is given by this expression, a over b plus 1 times x to the b plus 1 plus some additional unknown constant c. And we would need additional info, something such as this, to determine the value of that additional constant.